afternoon, dear students. We are on the CEC Gurukul lecture and we are in the series of electronic circuit where we are discussing the various components used in the electronic circuit. So today's lecture is the photoresist. What is a photoresist? We will discuss here types of photoresist, how we use photoresist, what is the working and principle of photoresist, and then finally we discuss the application and its advantages in this lecture. So, we discuss the photoresist. What is photoresist? Basically, photoresist is also known as the light dependent resistor. As the name suggests, photo plus resistor, it is a photoresistor is also known as the light dependent resistor. So, today's topic is the photoresistor and it is also called a photoconductor. It is commonly used material for this photoresistors are cadmium sulfide, selenium, aluminum sulfide, lead sulfide and the bismuth sulfide, and these are the manufacturing materials have the characteristics that the resistance value decreases rapidly under the irradiation of the light of a specific wavelength. It means when we are constructing the photoresistor, then we will choose such type of the semiconductors or the materials whose characteristics define the resistance decrease when it is irradiated with the light with a particular wavelength. So, on the basis of the wavelength, we choose the particular material for the construction of the photoresistor. The photoresistors are of three types. We will discuss later. This is the ultraviolet photoresistor, infrared photoresistor and visible light photoresistor. As the name suggests that in this type of photoresistor we use the ultraviolet light, infrared light and the visible light. Commonly used material for the photoresistors, as I discussed, that it is a cadmium sulfide, selenium, aluminum sulfide, lead sulfide and the bismuth, and these are the most commonly used. And the working principle of the photoresistor is based on the internal photoelectric effect. And basically the photosensitive resistors are formed by mounting the electrode leads at both the ends of the semiconductor photosensitive material, and then it is encapsulating in a tube with a transparent window. So, by the light fluctuation like dimming the circuit and the light switch are of the two applications of the photoresistors. So, photoresistors, that is why it's the light dependent resistor, and that is LDR. So, light dependent resistor, when the light falls, the resistance of the photoresistor decreases. So, this is because of the carrier generated by the light all participate in the conduction and make a drift movement under the action of the external electric field. So, the electron move to the positive pole of the power supply and the holes move to the negative pole of the power supply, so that the resistance of the photoresistor decreases rapidly. When we use the photoresistor, then there is a decrease in the resistance and the increase in the conduction. So, the photoresistor is a special type of resistor that is made of the semiconductor material such as sulfide or the selenized spacers, and its working principle is based on the internal photoelectric effect. Stronger the light fall upon a photoresistor, lower the resistance value. It works on this principle, that is a internal photoelectric effect, which is stronger the light, lower the resistance value. That we have to remember. So, as the light intensity increases, the resistance value decreases rapidly, and the bright resistance value can be as small as the 1 kilo ohm or the less. the photoresistors is very sensitive to the light. So, when there is no light, the photoresistor is in the high resistance state, and the dark resistance is generally up to the 1.5 mega ohm. So, the photoresistor is a type of resistor made by using the photoconductive effect of the semiconductor to change its resistance value according to the intensity of the incident light. It means the internal photoelectric effect works as in the photoresistor, and the type of resistors made by using the photoconductive effect of the semiconductor, in which change its resistance value according to the intensity of the incident light. So, it is also called the photoconductive detector, and the intensity of the incident light is reduced, then the resistance is reduced. So, the incident light is weak and the resistance will increase. As there is another kind of photoresistors, when the incident light is weak, resistance is reduced. The incident light is strong, resistance is increased. So, there are the various type of the photoresistors. So, photoresistors are generally used for the light measurement, light control, and the photoelectric conversion, that converting the changes in the light to change the electricity. As the light changes, the electricity will change. A commonly used photoresistor is a cadmium sulfide photoresistor, which is made of the semiconductor material. So, the photoresistors sensitivity to the light, basically it defines its spectral characteristics, is very close to the human eye's response to the visible light, like 0.4 to 0.76 mu mega meter, so micrometer. So, when the designing of the light control circuit, the light of the incandescent bulbs, small electric beads, or a natural light is used as a control light source, which is greatly specified by the design. So, in this we are having, you are seeing on the screen that this is the photo resistor, and the symbol is represented as a resistor with the two arrows as the light falling. On the left hand side is a schematic diagram, and on the bottom you are seeing that this type of photoresistor we use at the front of the circuit. You see, this is the photoresistor. Now, in order to obtain the high sensitivity, the electrode of the photoresistor often uses the comb-like pattern, which is formed by the vapor deposition a metal such as a gold or indium on the photoconductive film under a certain mask. So, the structure is of journal defined here. It is basically the semiconductor material is sandwiched in a mask, and that where we getting this. Photoresistor usually consists of the photosensitive layer, like a glass substrate we take, or we take the resin moisture or the proof film on the where we just put the material and the electrodes. The resistors are represented by the letter R and the RL, RG in a circuit. So, a photoresistor is made of the cadmium sulfide, and it is divided into epoxy, resin packed, and the metal packages done there, both of which are the wire like a DIP type. Epoxy packages photoresistors are divided into basically in this form like 3 millimeter, 4 millimeter, 5 up to the 25 according to the ceramic substrate diameter. We construct like that. So, what are the parameters and characteristics in the photoresistors? According to the spectral characteristics of the photoresistors, it can be divided into three types of the photoresistors, and these photoresistors, on the basis of its spectral characteristics, they are divided into three types, like ultraviolet photoresistors, second is the infrared photoresistor, and third is the visible light photoresistor. And these type of resistor are used according to its requirement. We use these three type of resistor. So, what are the main parameters or the characteristics used in the construction of the photoresistors are: number one, we will take the parameter which is the photocurrent and the bright resistance. Because photocurrent we are generating the current as a light fall, as the intensity fall upon it. So, the photocurrent and the bright resistance is the one of the parameter, in which under a certain applied voltage the current flowing is called the photocurrent. The light is irradiated and the ratio of the applied voltage to the photocurrent is called the bright resistance. So, bright resistance is one of the parameter which is the photocurrent, which is the current flowing in, which is the light irradiated and the voltage applied, that is its ratio will give the bright resistance, and which is usually expressed by the 100 Lx. Next parameter is the dark current or the dark resistance. What is the dark current and dark resistance? Under certain applied voltage, the photoresistor is called the dark current when there is no light. That is defined as the ratio of the applied voltage to the dark current is called the dark resistance. So, when there is no voltage apply, or when the no light is fall, and the ratio of the applied voltage to the dark current is called the dark resistance, and it is usually expressed by the 0 Lx. The light intensity is measured with an illuminance meter, and its unit is LAX, and that is represented by the Lx. That is why it is a 0 Lx, illuminescence meter. Now, the third parameter is the sensitivity. Sensitivity refers to the relative change in the resistance value, dark resistance, when the photoresistor is not illuminated by the light, and the resistance value, which is the bright resistance, when illuminated with the light. The sensitivity refers to the relative change in the resistance value, that is the dark resistance, and when the photoresistor is not illuminated by the light, then the resistance value will be the bright resistance, and when the illuminated by the light. So, both are defined as the sensitivity, as light illuminated or light is not illuminated. Next parameter is the spectral response. The spectral response is also called the subspectral sensitivity, and which refers to the sensitivity of the photoresistor under the irradiation of the monochromatic light with the different wavelength. When the light fall upon the photocell, then the spectral response we will get according to the light wavelength of the light falling upon the photo register. So, if we plot a sensitivity at a different wavelength, then we can get the spectral response curve, and that will define the response curve of the photoresistor. Next is the illumination characteristics. Illumination characteristics refers to the characteristics of the electrical signal output by the photoresistors as a function of the illumination. As the signal output we will get according to the illumination of the light, that define the illumination characteristics. It can be seen from the light characteristic curve also. When as the light intensity increases, the resistance value of the photoresistor starts to decrease rapidly. If the light intensity is further increases, so the change in the resistance value decreases, and the gradually becomes the at a point of the gentle point, we will say. In most of the cases, these characteristics are of the non-linear form. Next parameter is the volt ampere characteristics curve. That is the certain under that we will get the under the certain illumination. The relationship between the voltage and the current applied across the photoresistor is called the volt ampere characteristics. Relationship between the voltage and the current applied, that is the volt ampere characteristics. At a given biasing, the greater the light intensity, larger the photocurrent. Under a certain light intensity, larger the voltage applied, larger the photocurrent. Here here we can have the changes in the voltage and the current according to the according to the variation of the light. So, however, the voltage cannot be increased indefinitely because any photoresistor is limited by the rated power. So, maximum operating voltage and the rated current will define its output. So, exceeding the maximum operating voltage and maximum rated current may cause the permanent damage of the photoresistors. That's why its value will be varied. So next parameter is a temperature coefficient. As a photoelectric effect of the photoresistor is greatly affected by the temperature. Some photoresistors have a higher photoelectric sensitivity at a lower temperature, but lower sensitivity at a higher temperature. So, the one of the parameters is also the temperature, where we are using, at what temperature we are using the photoresistor. Next is the rated power. That rated power refers to the power that the resistors can consume in the certain line. So, when the temperature increases, power it consumes decreases. In the other parameters, we have the frequency characteristics. First is the parametric characteristics, and next is the frequency characteristics. In this type of photoresistor, when the photoresistor is irradiated with the pulse light, it means the frequency is changing. Now, we are not using a continuous source, but here we are using the pulse light. So, the photocurrent takes a period of time to reach a stable value. After the light is stopped, the photocurrent is not immediately 0, and this is the time delay characteristics of the photoresistor. When it is not immediately go to 0, the photocurrent not immediately go to the 0, then it is the time delay characteristics. Due to the different photosensitivity, the resistance delay characteristics of the different material, their frequency characteristics are also different, and resistance delay define the frequency characteristics, and the use frequency of lead sulfide is much higher than that of the cadmium sulfide, but the delay of the most photoresistor is relatively large, so it cannot be used in the application that require the faster response. So, we are having the how this photoresistor work, that we will discuss in the further lecture. As the light fall upon a photoresistor, then its resistance decreases, and how it will working principle we will discuss in the next lecture. Thank you very much.